Welcome to this video on geometric sequences. By the end of this video, you should be able to define a geometric sequence, determine if a sequence is geometric, find a common ratio and the next three terms of a geometric sequence, write the explicit formula for a geometric sequence, and use the explicit formula to find a term in a geometric sequence. Alright, so a geometric sequence is a sequence of numbers in which the common ratio between consecutive terms is constant. We have talked about the arithmetic sequences. They had a common differences, and that's when you added or subtracted. But a common ratio is when you're going to multiply by the same value each time. If you were to graph this geometric sequence, it would resemble an exponential function. So we're going to use a formula very similar to the exponential function formula when we go to write our equations. Now, to determine if a sequence is geometric, we want to look to see if there's a multiplication or division pattern going on. So these numbers are getting bigger, so they'd be multiplying, so we want to check. Using multiplication, you'd say 4 times 2 to get to 8. 8 times 2 is 16. 16 times 2 is 32. And 32 times 2 is 64. So this is a geometric sequence, and it has a common ratio, meaning a multiplier of 2. And then, as before, you'll have to be able to identify the first term also. Okay, so let's try this again. Let's skip over to number 3. Now, notice these alternating signs. Negative, positive, negative, positive, negative, positive. That means whatever you're multiplying by is negative. So let's just kind of take a look. To get from negative 3 to positive 6, if you multiply by a negative 2, that would work. Try it again. 6 times negative 2 is negative 12. Negative 12 times negative 2 is positive 24. And positive 24 times negative 2 is negative 48. So this is a geometric sequence, and it has a common ratio of negative 2. All right, so let's try, you're not always multiplying. Sometimes you could be dividing also. So let's take a look at number 4 here. Do you see how these numbers are getting smaller? So you want to look at what's happening each time. So 56 divided by 2 is 28. 28 divided by 2 is 14. 14 divided by 2 is 7. And it would keep going. Now, the way this formula works is you can't really divide. If I want to show dividing by 2, that's really multiplying by 1/2. Okay, because the way the formula is set up, we want to use this multiplication. So dividing by 2, so I have divide by 2, and then we're just going to put the 1 on top. Let's take a look at 5. These are getting smaller, so we're going to check. To get to 80 to 40 using division, I'd have to divide by 2. That'd give me 40, but 40 divided by 2 is not 30, so this is not a geometric sequence. All right, and now let's look at this one. Now this guy, he has negatives on every term, okay? Because they're all negative, whatever you're multiplying by is actually positive. Well, let's just take a look. This is negative 8 to make it a 32 if I multiply by a positive 4. Because negative 8 times positive 4 is negative 32. Negative 32 times positive 4 is negative 128. Negative 128 times positive 4 is negative 512. So this is a geometric sequence with a common ratio of positive 4. All right, if you remember when we graphed our exponential functions and we're looking at them previously, you notice that they could get really big or really small pretty quickly. So let's watch what happens if we follow the pattern. So let's see if we can find the next 3 terms of the sequence. So 3 times what would give me 12 would be times 4. And let's double check. 12 times 4 would give me 48. So we want to do the same thing. 48 times 4. So when I use my calculator, I am going to get 192. They said the next 3 terms, so we got 2 more times 4. And when I put that into my calculator, I got 768. Look how quickly it grew. Just in 1, 2, 3, 4, 5 terms, we're already up to 768. And if I multiply that by 4, I don't even have room. The last term would be 3,000. 72. I just kept following the same pattern. Let's look at number 8. Notice the alternating signs. That means whatever you're multiplying by is negative. So to get from 6 to 12 through multiplication, it'd have to be times negative 2. Positive 12 times negative 2 is negative 24. Negative 24 times negative 2 is a positive 48. Positive 48 times negative 2 is negative 96. And then negative 96 times negative 2 is a positive 192. And we're just following the multiplication pattern. Now this guy's getting smaller. Notice, if you can't tell what's happening, I'm not really sure what this pattern is, take the second term, divide by the first term. So we're going to put into our calculators 135 divided by 405. Okay, so we have 135 divided by 405. And 0.33, that's the same as multiplying, dividing by 3 is really what that means. So 0.333, going on and on and on, is the same as multiplying by 1/3. Okay, so it's going to be something that we remember. We're actually dividing by 3 each time. 135 divided by 3 is 45. 45 divided by 3 gives us 15. 15 divided by 3 is 5. Now for the next one, 5 divided by 3 doesn't give us this whole number, so I'm just going to write it as 5 divided by 3. Okay, so fractions do happen. All right, now we're going to learn how to write the equation. We can probably identify our pattern, so I want to move on to writing the equations. So some of this should look pretty familiar after seeing our arithmetic sequences. This a sub 1 is still whatever the first term is. R is your common ratio. What are you multiplying by? And then n minus 1 in the parentheses will remain. Now looking like this is the same equation as our exponential functions that we talked about before, a times b to the x, a times b to the x. Okay, we've got a couple special notes because we're talking about sequences here, so we know how to plug everything in. Okay, so we still need to know the first term and the common ratio. So the first term here is 6. Remember, that's the first, second, third, fourth. Okay, and your common ratio, so to get from 6 to 24, I'd have to multiply by 4. And then let's check, is 24 times 4 is 96, times 4 is 384. I'm just verifying that it's multiplying by 4. So my common ratio is 4. So this says, put your first term in the parentheses, put what you're multiplying by to the n minus 1. That's the whole equation. That's all you've got to do. Now to find a particular term, we're just going to plug it into the exponent in the n spot, and then we'll use our calculator. So we have 6 times 4 raised to 8 minus 1 is 7, so I'm just going to go ahead and put the 7 in. And look, that's a really big number. I got 98,304. Because exponential functions can grow really fast or decay really fast. So they can get really, really big or really, really small quickly. Okay, so the first term here is 6. By the time we got to the 8th, we're already up to 98,000. So let's try this again. Our first term is 1. And if we look at this, I can kind of see a pattern, but if you're not sure, divide the second number by the first number. So 6 divided by 1 is 6. And just double check. 1 times 6 is 6. 6 times 6 is 36. 36 times 6 is 216. So we're multiplying by 6 here. That's our common ratio. We're going to use our formula that says take your first term, put your multiplier here, and n minus 1. There's our equation, our formula. Now we can find the 10th term by plugging 10 in for n. So I say 1 times 6 raised to, well, it's 10 minus 1, so I'm just going to put a 9 into my calculator. That's a very large number. That is 10,077,696. So we didn't go too many steps in, only 10. So this is 1, 2, 3, 4. We only went 6 more, and we're already up to 10 million. All right, let's try just a couple more. We're not going to do all of these. Let's look at 13. I want to do 13 because our numbers are getting smaller. Okay, the signs are all the same, so that means our number that we're going to be working with is positive. Now, because it's getting smaller, I'm dividing by something. If I'm not sure what I'm dividing by, I'm going to take the second number divided by the first number, and I got, 0.333. Remember what I said up here, that 0.333 means 1/3. So you're actually dividing by 3. So your common ratio here is 1/3. Negative 18 divided by 3 is negative 6. Negative 6 divided by 3 is negative 2. Negative 2 divided by 3 will just be negative 2/3. Okay, if we were going to continue on. Now we are going to write our equation. Our first term is negative 18. So we're going to take our first term times our multiplier to the n minus 1. That's your entire equation. Now we want to find the 8th term, so we're going to say negative 18, 1/3, and we're going to plug 8 in for n, and then we'll use our calculator. Negative 18 times 1 divided by 3, which is 1/3, raised up to 8 minus 1 is 7, so I'm just going to put 7 in. And it gives us this tiny, tiny number, and that number was negative 0.00082. So this is a decay. It's getting really close to its asymptote down here. This one is a growth. It's getting really big on the right really fast. All right, for our next one, I'm noticing that our numbers are getting smaller, which means we're multiplying by a fraction. And to figure out what that fraction is, we're really got to see what is dividing, what number is dividing each of these. So I do know that negative 8, to get to negative 2, if I divide it by 4, and I'm just going to double check, negative 2 divided by 4 is negative 1/2. So that means our common ratio is 1/4. Because we're dividing by 4, that's what the 4 underneath is, and we're putting the 1 in top for a placeholder. And then our first term is negative 8. So we'll take our first term times our multiplier. Remember I said it's a decay when it's getting smaller, so there's that number next to the exponent is less than 1, to the n minus 1. There's our equation. To find the 5th term, I'm just going to plug 5 in. That's 4 raised to the 5 minus 1. And I'm going to use my calculator. 1 divided by 4 for my fraction raised to the 4 is negative 0.03125. Okay, hopefully we're finding these to be pretty easy to plug in and find terms. Let's try a couple more. All right, here on the back I've given us a little bit of a puzzle. We're just going to do a couple of these. And we're not going to do any that is this kind. Our standards are a little different. So what if I say, I want to know what a sub 1 is. I want to know what the first term is if I know that the 6th term is 64 and the common ratio is 2. So here's what we're saying. I don't know the first term. So I'm going to make a table of values here. I don't know the 2nd term. I don't know the 3rd term. I don't know the 4th term. I don't know the 5th term. But I do know that the 6th term is 64. Okay. Now, this says the common ratio is 2, which means if I'm going to go this way, that means multiply by 2. But if I'm going to go the opposite direction, I'm going to do the opposite math. I'm actually going to divide by 2, and I'm going to work myself back to this first term. So 64 divided by 2 is 32. 32 divided by 2 is 16. 16 divided by 2 is 8. 8 divided by 2 is 4. And 4 divided by 2 is 2. That took me all the way back to the first term. So the first term of this sequence is 2. Right? So make yourself set up so you can see all the ones you've got to fill in, and do the opposite thing. This says multiply by 2, so the opposite of multiplying by 2 is dividing by 2 to work ourselves backwards. Let's try this again. All right, so we want to know the first term, and they're giving us the fourth term. So 2 we don't know, 3 we don't know, 4 we don't know. Okay, or we do know. The fourth term is 8. Going this way, we're going to multiply by -2. That means going the opposite direction, we're going to divide by -2. So 8 divided by -2 is -4. -4 divided by -2 is just a +2 because negative, negative. Okay. -2 divided by -2 is -1. Notice that alternating signs, negative, positive, negative, positive. It's because our common ratio was a negative number. All right, this is the same problem. It's just we had to go a little further out, so I'm not going to do that one. So let's go ahead and look at these word problems, and then you'll be ready to go on your own. So we have a store manager plans to offer a discount to some sweaters according to this sequence: 48, 36, 27, 20, 25. Write the explicit formula for the sequence. What would be the discount on the 8th sweater? So first, let's write a sequence. We need the first term, so we know that's 48. We need to know how it's being multiplied. Well, it's actually looks like it's being divided because the numbers are being smaller. But here's what we're going to do. Remember, take the second term divided by the first term, and that's what's going to go into your parentheses here. So I'm going to take 36 divided by 48, and I got 0.75, so I'm going to put 0.75 here. That's all we got to do. And the equation says put n-1 right there. There's your equation. This equation represents what they're talking about right here. Now, if I want to know the 8th sweater, we're going to plug in 8, 0.75, and then we have 8 minus 1. So we're going to take 48 times 0.75, and we're going to raise 8 minus 1 is 7, so I'm just going to plug in the 7. And I got 6.41. I'm going to round because this is money. So this discount on the sweater will be $6.41. Okay, 2 more and we'll be done. So when we have a radioactive substance and decays, measurements of the amount of remain constant over intervals of time. So it makes a geometric sequence. So here we have this amount of F118 remaining after different constant intervals. We're going to write the formula. So when there's 0 time, when there's 110, but we want to see what's happening. How are these guys changing? This is changing by 110 each time, so these are equidistant apart. Okay, so I'm not sure, so I'm just going to say 130 divided by 260 to get my multiplier. 130 divided by 260 is 0.5. So my first term is 260. My multiplier is 0.5, and then I'd have the n-1. From here, they could ask any question, like, because this is really the first term, second term, third term, fourth term. They could ask me, what is the, when it's after this much time, and I'd find out how many steps out that would be and plug that number in. Okay. All right, now our last one. So we have this game company. They make video game consoles, and their sales data is shown in this table. We're going to write an equation that represents the sequence and predict what sales will be in 2022. Okay, so we need to see how these are changing. Take the second term, divide it by the first term. So we have 18 divided by 15, which gives us 1.2. All right. So let's go. 18 times 1.2 is 21.6 times 1.2 is 25.92. So that is our multiplier. So we know what's in the parentheses is 1.2. Our first term is 15. And then we have n-1. That's our formula. Now they want to know what will the sales be in 2022. Okay, and so that's going to be 11 years from this first term. Okay, so we're going to plug in 11. So I'll say 15 times 1.2 raised to the 11 minus 1, which is 10, is 92.87. All right, hopefully that was helpful. Let me know if you have any questions, and I'll see you in class.